Today we're going to talk about multiplying and dividing rational expressions. Remember, a rational expression is just some polynomial in the numerator and in the denominator, expressed as a ratio, thus the name rational. We tend to think of rational expressions as this red example at the bottom, where you have polynomials that can be factored and canceled, and they have graphs with asymptotes and all that stuff. Technically, this blue example is also a rational expression. It's just that they're all one-term polynomials. You would tend to see an example like this in your rules of exponents earlier, perhaps in Algebra 1. But we'll revisit a little bit of that to talk about multiplying and dividing. And we actually do multiplying and dividing before we do adding and subtracting because it's a little bit easier when we're talking about fractions. If you want to we'll just do a little over on the side here. If you want to add two fractions, like 1/2 plus 2/7, you have to take the time to get a common denominator and then add, and you leave the denominator the same, add the numerators. If you want to multiply 1/2 times 2/7, you just multiply the top and multiply the bottom. So that's 2 over 14, which would reduce to 1/7. And if you had canceled early on, we could have realized that the 2's cancel and you just get 1/7 anyway. There's a lot of parallels between what we're doing right now and those old rules of adding and multiplying fractions. So let's start with this blue example. If you have an addition or subtraction, you have to be careful with what you cancel. If you have two fractions that are multiplied together, it's a canceling free-for-all. Anything that matches top and bottom, you can eliminate. So, for instance, I see two b's at the top, b squared. I can get rid of two b's from the top, and then if I get rid of this cube down here, that's getting rid of two b's on the bottom and leaving one b. I see a couple of a's on the bottom, and I see a squared on top, so I can get rid of those, leaving me with four a's on top. What about c's? I see two on top, one on the bottom. So I'm going to get rid of one from each, leaving me with one c on top. So it looks like just my variables, I've got four a's and a c on top and a b left on the bottom. So what about my coefficients? Well, same thing. Just cancel what you can. If you want to multiply 15 by 14 and then multiply 21 by 6, and then simplify the fraction that's left over, that's fine. That would be easier with a calculator. But you can cancel stuff the whole way through. So 21 and 14, I can divide each one of those by 7, leaving me with 3 on the bottom and 2 on top. Okay, so now I see more stuff. I see 15 and 3. So I'm going to switch colors since I've already used red for that 3. But I'm going to get rid of that 3 and change that 15 to a 5. Basically divide both of those by 3. So now I see a 5 on top, a 2 on top, and a 6 on the bottom. So that's 10/6, which I could go ahead and do, or I could divide the 2 and the 6 both by 2, eliminating the 2, and changing that to a 3. So really, honestly, the hardest part about this is keeping track of everything you've canceled out. It's just a bunch of canceling, simplifying fractions. Reducing is not necessarily the best term, because reducing implies we're making something smaller. We're not changing the value here, we're just changing the way it looks. We're simplifying it. So it looks like I'm left with a 5 on top, a to the 4th, and c. And on the bottom, I'm left with a 3 and a b, and that should be it. 5a to the 4th times c over 3b. All right, it's been simplified. It has been multiplied. All right, just a bunch of canceling. All right, so now a more traditional, what you would think of as a rational expression looks like this. All right, so what we want to do if we have this format is you want to get everything factored. Usually there's going to be some stuff that will cancel out, but you don't see it unless you see the factors. So if you've got, there'll be a lot of quadratic expressions that you can factor. In this case, that's all we have. And then cancel what you can. Also, we'll talk about how this is divided by, how that's different. And you should remember from a long time ago that dividing by a fraction is the same as multiplying by its reciprocal. So let's just go ahead and as we factor, we'll flip that second fraction over. So the first fraction, is going to factor on top. All right, y and y. It's how we would get y squared if we were to multiply this back out, or FOIL, you might call it. The 15 is a plus 3 and a plus 5. 3 times 5 is 15. 3 plus 5 is 8. So that's that top expression factored. And then y minus 6, right now, we have nothing to do with that yet. All right, so I'm going to multiply by this one flipped over. Y squared minus 9, hopefully you recognize as the difference of two squares. Factors to y plus 3 and y minus 3. And then this expression that was on the top, I'm going to factor and put it on the bottom. So really, the difference between multiplying and dividing is not even really a concern. Just flip it over, and then they're all multiplications. But anyway, that expression on top will be a y and a y. And now I need two factors of 18 that add up to negative 9, which would be negative 3 and negative 6. So we've talked some recently about factoring. These are kind of tame factoring examples, but they can get a little bit more in depth. Just make sure the first thing you think is to factor. Now, just like I would take, two A's from the top and cancel them with A's from the bottom up there, if I see something on the top and the bottom, I can get rid of it. So these y minus 3 terms, here and here, we can cancel. Nothing else. I see a y plus 3, but they're both on the top. I see two y minus 6s, but they're both on the bottom. So there's nothing else that matches top to bottom. Here's something you know, but people always try to do. You never want to cancel something that is being added to something else. Never cancel part of a binomial. People will want to cancel that y with that y and eliminate both of those. That you can never cancel part of a binomial. If you're not sure why, just ask yourself. Is this 2 plus 3 over 3 equal to 2? Cancel the 3's. Obviously that's not true. So don't try to do that with a polynomial. So what's our final answer? Well, I see a couple of y plus 3's on top and a y plus 5. Now, I could square all of that out, and there might be a time when I need to, but let's just leave it, and we'll square the y minus 6 on the bottom. If you have to square it out, you can, but there's no use doing it right now just for sake of squaring it out. Okay, so multiplying and dividing these, the key is, remember, if it's division to flip over the second term. Other than that, factor and cancel, and then just multiply what's left over. Similar to our old exponent stuff, this right here is more like what we're talking about now. All right, so we're going to make that one a quick video, and I'll see you next time for adding and subtracting. Young out.